This is geotrig, lesson 9, day 2. We're going to continue on with proofs today. I do believe there are 2 more left. So this is the next one. And it says that we are given that angle E is congruent to angle H. And line segment EF is congruent to line segment HF. Show that line segment AF is congruent to line segment DG. So obviously our first statement should be what is given to us. So yes, angle E is congruent to angle H, and EF is congruent to HF. What was the question?
What does the line like above it mean?
Line segment. Remember, if it's, AF with a line over the top, it's line segment. If you put lines or arrows on it, it's line AF. If you put just one arrow, it's ray AF. You remember that?
Sure.
It's all different ways of representing different things. And the reason for all of this stuff we just stated is the what? It's given. Oops. That's always your first line, guys. State what's given. Next. It's a given stuff. It's angle E is congruent to angle H. Line segment EF is congruent to HF. Line segment HF. Just restated what was there. And of course, what will I do with the diagram? Not rewrite it, but I'm going to fill it in. I'm going to put the tick marks where they belong. Angle E and angle H. That's here and here, right? Is everybody okay with that? What else are we given?
You're given
EF and oh.
Angle, hold on. HF.
I think that should be G. Correct. Sorry, let's go back up and fix that.
Yeah. Well, you got HF up there, so.
I know. Whoops. Is it okay if I change that? That makes more sense to me.
Yeah.
It will to you eventually. Now, it wants us to show that AF, where is A? Where am I getting this problem from, guys? Okay. Second fix, change this to DF. Because what I want to show is this thing right here, DF, is congruent to DG. Okay? Now, if I wanted to show that those two things are congruent, they kind of seem to be, with all the rest of the information, part of the 2 outside triangles, right? There was something we found yesterday that if I can prove those triangles to be congruent for any reason, then the rest of it all has to be congruent by what? What was that fun thing that you guys tried saying?
Reciprocity.
Starts with a C, ends in a C. C, P, C, T.
Oh, CP,
Corresponding parts of congruent triangles are congruent. CP, C, T, C. So, Our last line, guys, is going to be that DF is congruent to DG by CPCTC. So thinking backwards, that means I need to prove those two outside triangles are congruent. So how do we make that happen? This one's special because it's a special type of triangle. Does anybody recognize what kind of triangle this is?
Equilateral.
It's not necessarily an equilateral.
Up to what's that?
We can't say that. I can't say that.
Donkey.
Guys, at no point did I just ask you to tell me what the congruency is. I asked you what kind of triangle this is. Well, okay, it's an acute triangle, okay, because all the angles are acute. Fantastic. But it's more than just an acute triangle. It's an isosceles triangle. Why? Why is this an isosceles triangle? Two angles are the same. Guess what, guys? The only way for these two angles to be the same as base angles of the large triangle is if it's an isosceles triangle. And if those two angles are the same, what can we say about the sides opposite them? So therefore, this side and that side are congruent. So we got to state that. Line segment, what?
EF.
Not EF. We're not talking about EF.
ED.
ED is congruent to line segment
HD.
HD. Why? Bonch, what are we saying?
What?
You said definition?
Oh, you said high definition.
Oh, high definition. But it is definition. Definition of what?
Of a triangle.
What kind?
Isosceles.
Definition of isosceles triangles, guys, says that the pairs of corresponding sides opposite their corresponding angles that are the same have to be the same. Hey, do we have enough information now to say those outside circles are the same? Are congruent? By what? Why are they the same? They are congruent by, now state the similarity, or the congruence factors.
Hypotenuse leg.
Hypotenuse leg. No. Hypotenuse leg only works with guarantee, they have to be what kind of triangles? A right triangle. That's not a right triangle. It is SAS. So the reason for 3 is side, angle, side. But we have to state it. And you have to state it in the correct order. Here's the fun thing. The first order doesn't matter. So someone tell me which one of those triangles. Triangle. Go.
EDF.
EDF. EDF is similar to. Now it matters. I have to follow the same order as EDF. So E was the single band, so yes, H. Then we move to D, and then G. We now have the vertices in the correct order. This allows me to show, without even having the triangles there anymore, what sides are corresponding and what sides are congruent. And even angles. We know that E is congruent to H, D is congruent to D, F is congruent to G. Now, in step 4, if we know two triangles are congruent, that means anything about them is congruent because of what again? C, P, C, T, C. Done. So, the last problem we're going to do is a triangle that has been cut with some lines that connect B to G and D to F that form two smaller triangles in there. I'm not going to have enough room to put this in here and actually be something you can read. So yes, it's listed above, and the reason is, for number one, it's all given to us. So you really should go back and list or put on the picture all the stuff that's talked about. So AG is congruent to EF. AG, EF. Oh, those are the two bottom pieces of the smaller ones, right? Everybody okay with that? CA, CE. CA, CE. Ooh, that means all of this and all of this, right, are the same. It'd be kind of weird to put a tick mark where B and D are, because it just would get in the way, right? Because it wouldn't be individual pieces, it'd be the whole thing. What else is it telling us? B is a midpoint from C to A. D is a midpoint from C to E. Now, it's great that it told us that, but I'm going to use that information to say something. What would I say? Right. Wait. Not yet. I like that AB is congruent to BC first, because that's the definition of a midpoint. The midpoint is the point in the middle which cuts it in two pieces, right? So I'm okay, guys, with saying this, that AB is congruent to BC and CD is congruent to DE for the exact same reason. Definition of midpoint. Definition of midpoint says that they are the same. Now I can go back and draw something on them. And then over here, a circle and a circle. I don't know. But maybe, now we go back to what Stella said. And Stella said, what?
AB is congruent to DE.
Is that okay? Can we make that jump? AB is congruent to DE.
Yeah.
Why? Sometimes it's more than just a word or two. You actually have to write a sentence out. What would that sentence or words be? Why are those two the same? The both midpoint of what? Of congruent segments. Midpoints of congruent segments. So therefore, I'm going to change colors so that we can actually see it. But I think we should say that this would be a 3-line and 3-line. Ooh, do we have enough to say that they're congruent? No. Yeah. What else do we want to say?
The CD.
CD. What about CD? CD and BC?
BC, yeah.
We could say those are also the same, right?
Yeah.
But those even inner triangles?
No.
No, not necessarily. So it might not help us. We could state it. It might not help us, though. I don't think it's going to. So? BG and DF. What can we say there? That's actually BG and DF are what we're trying to show. So I don't think we have enough information yet to state that they are congruent. The HL. Hypotenuse leg. Can we guarantee they're right triangles? No. Guys, Kevin wanted to use HL. It's a valiant effort for the fact that we do have the hypotenuse, we do have a leg, but the only thing that's missing is the fact that it's not telling us the right angles. So no, I cannot use that. Yeah.
AE.
AE. What do you mean?
Like the angles.
Why?
It's, the whole triangle is an isosceles triangle.
So angle A is congruent to angle E because of the definition of, again, what?
An isosceles
Yeah.
triangle.
Definition of isosceles triangle, guys. It goes both ways. If the angles are the same, that implies that the sides opposite them, or they open to, are the same. If the sides are the same, that means the angles opposite them have to be the same or congruent. Do we have enough information to state congruency now? And hopefully you guys say yes. Someone give me triangle 1. B, G, A is congruent to triangle D, F, E. Have to be the same order. And the reason for step 5 is side, angle, side. Side, angle, side first. You got to state congruency first. And 6, we state BG is congruent to DF by CPCTC. Done. Homework day 2 is worksheet proofs. Have a great day.